Today I'm going to be talking about linear probabilistic modeling. Now you all must be wondering, what is linear probabilistic modeling? Well, it's a statistical function that allows us to see, wait for it, into the future. That's right, statistics is like a third eye for engineers. Just kidding, seeing into the future is impossible. No one can do that. Don't think you can do that. However, it does allow us to predict outcomes based on past events. We use data we have collected to create a regression line that can help us analyze the probability of future occurrences. The x-axis is the setting for our data points, and y is a real-valued response. You may notice that the y-axis on the graph is limited to values of 0 and 1. Why is that, you may ask? Well, I'm so glad you asked. Linear probabilistic modeling is often used as a tool to model binary outcomes. These outcomes are the real valued response in the y-axis to our data points. 1 is equal to success, and 0 is equal to failure. This is not an exact calculation, since a binary model doesn't have a normal distribution. However, you can think of it as a preliminary estimate before using more exact techniques, as long as the probabilities are not too close to 0 or 1. An example of linear probabilistic modeling could be testing different prosthetics to see how long they are likely to last, and which one is the most reliable. In such a case, 0 would mean failure of the prosthetic, and 1 would mean the success of the prosthetic as long as it is surviving. The x-axis would model how long the prosthetic lasts, perhaps in hours or even days. Here we see a constructed table of our x and y values, which give us our data points, and from these our regression line is constructed. For the prosthetics application, we may want to know how likely it is that a certain prosthetic will fail after a certain amount of time, what our max working expectancy is, or perhaps whether the prosthetics are not consistent and are therefore unreliable. Linear probabilistic modeling is not complex or even exact, but it is an easy, simple tool we have to predict things and make inferences quickly, which is very valuable in a fast-paced career like engineering. Time is money, and linear probabilistic modeling saves time. So remember to always KISS and tell others about it. Thanks for watching the video. I hope you learned a little bit more about linear probabilistic modeling, and as the memes say, have a great day.